Good day to all of you. Today we shall discuss on multi-thread modeling. Before that, let us have some discussion regarding basics. So computer can process the information. It will be having the memory, processor or CPU and I/O components such as graphics storage devices, networking. CPU executes the given computations. It can read and write to memory. This is the computer hardware that can do the work. This is the memory space in which user programs are stored. When given execution, they are called as user processes. Anyway, user processes in the memory. They are to be executed by the computer hardware. In between, we have operating system which acts as the interface between user and the computer hardware. Kernel is the core of operating system. Okay. User processes are actually created in user space, that is part of the memory which is dedicated for the user. These user processes are controlled by kernel. Kernel also enables inter-process communication with each other. Okay. So the programs can be executed in two modes. One is user mode, kernel mode. User related programs or set of instructions, they are executed by the computer in user mode. Operating system related instructions are executed in kernel mode. So in user mode, user cannot execute operating system related instructions. Then error occurs. Kernel helps privilege separation for security. So it protects the operating system from user. User cannot illegally execute operating system related instructions in user mode. Thread is a unit of execution inside a process. It can also be called as flow of control inside the process. There are two types of threads, user thread and kernel threads. User threads are created by user and they are supported above kernel. They are managed without support of kernel. They are controlled by user through API, application programming interface. That is through threads related library functions. Kernel threads are supported and managed directly by OS. The system can run efficiently when there is relationship between this user threads and kernel threads. Kernel is the core of operating system. Operating system is the software that acts as the interface between user and the computer hardware. So what user threads and kernel threads are there? There has to be some relationship between established, then only the whole computer system can work efficiently. How to establish the relationship between what are the different types in that is called as multi-thread modeling. So multi-thread modeling is the type of relationship between user threads and kernel threads. There are three common ways of establishing relationship between user thread and kernel thread. They are many-to-one model, one-to-one model and many-to-many model. So many user threads associated with single kernel thread, that is many-to-one model. One user thread associated with one kernel thread, like that every user thread being associated with one kernel thread, that is called as one-to-one model. Many user threads being associated with many kernel threads at the same time, that is called as many-to-many model. Next, let us see in detail one by one these multi-thread modeling. In many-to-one model, many user threads are associated with one kernel thread. Thread management is done by thread library in user space. So user will have created these user threads. He will create single kernel thread. He will manage these threads, the relationship between the two through library functions. That is done by user only, hence controlling is efficient. But if any thread if makes a blocking system call, then the kernel is blocked, hence entire process will also be blocked. That work will not be done because all the threads belong to one process. because one kernel is blocked by one thread here. That kernel, when blocked, then whole process will be blocked. Its execution cannot be continued. This is what is limitation or disadvantage of many to one model. Second one is one to one model. So each user thread is mapped to one kernel thread for each. So this provides concurrency operation in parallel. Okay, if any one thread makes a blocking system call to the kernel associated, only that is blocked. So only that part of work is blocked, but the remaining kernels will continue the execution of remaining threads. Here creating the user thread also requires creation of corresponding kernel thread. Hence it burdens the performance of application. This is one disadvantage. And the number of threads supported by system is also restricted. So what is the meaning of that? So here 4 kernels are there. Then in this single process 4 threads can be created. So one on each kernel. It can work. Suppose if 5 threads are there in that process, then that work cannot be done. Because 5 threads, only 4 kernels, then 1 thread for each kernel means 5 kernels are required. So such an application process cannot be executed. Okay, the number of threads supported by the system is restricted, and this kind of model also burdens the performance because creating of user thread also requires creating of kernel threads in this. Next, third one is many to many model. That is, many threads are associated with many kernels. So depending on what type of application or what machine is there, the number of kernel threads may be specific. So the developers or programmers can create as many user threads as necessary corresponding to kernel threads. They can run in parallel on multiprocessor system. Multiprocessor system means one kernel in one processor. 3 kernels means 3 processors will be there. This is a multiprocessor system. So this thread can run in parallel. Hence execution can be done in parallel because it is a multiprocessor scheme. Then multiple threads are mapped onto multiple kernels. First point. Next, if any thread makes a locking system call to a kernel, then another thread can be scheduled for the work because other kernels and other threads will be working. Okay. So this is all about multi-thread modeling. I hope you understood. Thank you.